Welcome to this explainer, where we are going to completely transform you from a raw memorizer into an absolute Cambridge Physics 0625 master. We're going to achieve this by using what I like to call the ultimate structural spell for mastering action and reaction. Seriously, if you have ever sat there staring at a blank past paper, feeling like you know all the physics facts but you just have no earthly idea how to string them together to get those elusive top marks, you are in exactly the right place. Today, we are treating exam technique like a precise science. It's not about guessing what the examiner wants, it is about knowing exactly what they need to see. By the end of this session, you are going to walk away with a blueprint that works every single time you sit down to write. Let's get into it.
Our roadmap for today is super straightforward. We're moving from the common exam tracks that catch everyone out right into a concept-first interactive workshop. And we are going to wrap it all up with the foolproof step-by-step system that absolutely guarantees maximum marks.
All right, Section 1, the challenge. Let's take a hard look at the classic exam trap where rote memorization completely falls apart under the high-pressure environment of the exam hall.
Now, this is our necessity hook. Before we start throwing any formal physics jargon at you, you really must understand why this specific concept matters in the real world. That is how you build genuine cognitive ease. Just think about it for a second. When you step off a small, wobbly boat onto a wooden dock, why does the boat immediately push away from you in the opposite direction, potentially dropping you right into the water? Or think about when a massive rocket launches into the absolute vacuum of space. There's literally no air out there to push against, so how on earth does it actually accelerate? What physical effect, measurement, or prediction actually depends on understanding action and reaction? Look, if you just memorize the phrase, every action has an equal and opposite reaction, well, you have a nice decorative fact, but you absolutely do not have a working tool. And here's the secret. Examiners are actively looking to see if you have that working tool. They are testing your ability to reason through a totally unfamiliar scenario, not your ability to just act like a human photocopier.
Let's actually see this exact problem play out in reality. Look at these two flawed approaches to a real Cambridge past paper question side by side. The question asked the student to explain the recoil of a rifle using Newton's laws. So, candidate 1, Alex, completely overloads the page with raw physics facts, but there's zero analysis. Alex has frantically written down F equals ma, momentum equals mass times velocity, and drawn a bunch of chaotic arrows everywhere. It is a total brain dump. There's absolutely no coherent chain of thought, just a bunch of isolated variables floating around. The examiner is going to give Alex maybe one pity mark for mentioning momentum. On the other side of the screen, we have Sam. Sam rushes the question and entirely misses the command word requirements. Sam just writes, "The bullet goes forward, so the gun goes backward." Sam looked at the scenario, panicked about the clock ticking down, and rushed straight to a conclusion. Sam completely ignored the command word explain, which strictly demands that you lay out the underlying physics principles. Ultimately, both of these papers come back covered in red ink. Why? Simply because they lacked a structural framework to organize their thoughts.
So let's fix that. Welcome to Section 2, the strategy reveal. We're going to unpack the concept-first strategy that safely bridges the massive gap between everyday conversational language and precise, mark-scoring physics vocabulary.
This quote right here brilliantly illustrates our core philosophy. Insist on cause and effect rather than isolated facts. If you want to master physics, you have to prioritize the chain of cause and effect over simply memorizing a list of isolated formulas. When the examiner sits down with their cup of coffee to read your answer, they desperately want to see a story. Not a fictional creative writing story, but a highly logical narrative. A story where event A causes event B, which is strictly governed by formula C, resulting in physical observation D. If you just chuck formula C at them and move on, you have completely broken the chain and you drop the marks.
So, the crucial point here is applying a specific, four-step reasoning scaffolding. This acts as your Peel framework for physics. Before we break down exactly how this magic spell works, I need you to do something. Before we continue, subscribe to our YouTube channel, AC Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, let's break this framework down. Step 1, identify the quantity or phenomenon. Ask yourself, what are we actually talking about here? Is it force? Is it momentum? Is it acceleration? Name it clearly right out of the gate. Step 2, state the relationship involved. This is where your formulas or your core laws come into play, like naming Newton's third law. Step 3, explain the underlying physics. Why on earth does this relationship happen in this specific scenario? Step 4, connect it to an observation, experiment, or a real device. Bring it all the way back home to the question they actually asked you. This sequence is absolutely critical in physics because the highest scoring answers consistently show both deep understanding and practical application.
Let's head straight into Section 3, the transformation. We are going to see exactly how we can turn those flawed red-inked answers we saw earlier into beautiful green check marks using our brand new blueprint.
Let's contrast the common traps that students fall into against our absolute safest method. Looking at the common weaknesses, trap number 1 is writing down a formula without actually defining the variables. If you just scribble F equals ma on the line, you lose marks. You must specify that F is the resultant force acting on the object in question. Trap number 2 is quoting a process without linking it to a physical effect. Just saying Newton's third law happens doesn't actually explain to the examiner why a rifle violently kicks back into your shoulder when you pull the trigger. On the flip side, our safest method applies our 4-step spell flawlessly. Definition, relationship, explanation, application. First, you define the core idea. Next, you state the relationship. Then you explain the cause and effect chain. And finally, you apply it directly to the physical effect described in the prompt. Also, a quick pro tip: if the topic involves graphs, you must explicitly stress what the slope, the area, the direction, or the shape means physically. Never, ever leave a physics concept floating in a vacuum. You must anchor it to physical reality. Watch how explicitly linking slope, area, or direction back to physical meaning transforms Alex and Sam's answers. But hey, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's do a rapid 60-second rewrite for that rifle recoil question using our framework. First, identify the phenomenon. We state clearly that we are dealing with the conservation of momentum and action/reaction forces. Second, state the relationship. We write that Newton's third law states that if body A exerts a force on body B exerts an equal and opposite force on body A. Third, explain the physics. The expanding gases in the barrel exert a massive forward force on the bullet. Simultaneously, an equal and opposite reaction force is exerted backward on the rifle itself. Fourth, connect to observation. Because the rifle has a significantly larger mass than the tiny bullet, its backward acceleration, which is the recoil we feel, is much smaller, but its backward momentum perfectly balances the bullet's forward momentum. Boom. Full marks. Every single box on the examiner's mark scheme is checked, and you didn't even have to break a sweat.
It is time for Section 4, our interactive workshop. This is where you actually put the work in. You are going to analyze data, find the hidden flaws, and speed write under pressure.
Okay, let's dive into challenge number 1. If you scan these complex, real-world fields where action and reaction heavily apply, can you extract the core trend of how the physics actually helps us predict outcomes? Let's walk through them together, one by one. Look at engineering. We're talking about massive structural loads on suspension bridges pushing down and the concrete pillars pushing back up with equal force. Look at safety. Think about the crumple zones built into the front of modern cars. They are specifically designed to manage the reaction force during a high-speed impact, increasing the collision time to purposefully decrease the deadly force acting on the passengers inside. Look at transport. Huge jet engines are constantly pushing burning exhaust gases backward so that the gases thrust the entire plane forward. Energy systems. Massive turbines are turning because superheated steam pushes against the metal blades and the blades naturally push back. Medical technology. Think about the crazy magnetic force interactions inside an MRI machine. So, what is the core trend across all of these incredibly diverse fields? The trend is that every single engineered system on the planet relies on predicting the exact magnitude and direction of the reaction force. Think about it. If an engineer doesn't correctly calculate the reaction force of that bridge pillar, the bridge literally collapses. Action and reaction is not just some boring textbook chapter you memorize. It is the fundamental, non-negotiable rulebook for physical design.
Let's move straight into challenge 2. I want you to carefully identify the exact sentence in this sample paragraph that bleeds marks by giving an example without actually showing why it follows from the underlying physics. Listen closely to this flawed paragraph. When a person walks, they exert a force on the ground. According to Newton's third law, there is a reaction force. This is why walking is possible and why tires grip the road. Did you spot the flaw? It is that final sentence. This is why walking is possible and why tires grip the road. This is such a classic exam trap, and examiners see it thousands of times a year. The student has given a valid example, tires gripping the road, but they haven't actually shown a cause and effect chain. The examiner commentary on this would brutally read,
Candidate states an application but fails to explain the physical link. To fix this and get the marks, you must say, the person exerts a backward frictional force on the ground then exerts an equal and opposite forward frictional force on the person's foot, which is what propels them forward. Notice the difference? You must specify the direction and the specific type of force.
Moving to Challenge 3. In a moment, you should pause this explainer and take exactly 30 seconds to write one perfect paragraph that executes our 4-step cause and effect framework. Imagine the exam scenario is a balloon rocket, a simple balloon filled with air released to fly erratically across the room. Ready? Your internal thought process should look exactly like this. First, the phenomenon. It's thrust generated by expelled gas. Second, the relationship. It's Newton's third law of equal and opposite forces. Third, the explanation. The tightly stretched rubber of the balloon physically forces the trapped air backward out of the narrow nozzle. Fourth, the connection. That expelled air exerts an equal and opposite forward force back on the balloon, causing the physical observation we see of the balloon accelerating forward across the room. If you can mental map that efficiently in under 30 seconds, you are genuinely ready for any curveball the Cambridge 0625 paper throws at you.
Let's consolidate all of these powerful techniques into Section 5, the final system. This is a foolproof, 3-step approach designed specifically for dominating your exams.
These 3 rules are your holy trinity for guaranteeing top marks. You need to accurately decode the question's command word, properly apply our 4-step framework, and strictly follow the time management matrix. Let's break them down. First up, command word decoding. If the Cambridge paper says state, you literally just give the raw fact and move on. Do not waste time. If it says describe, you say what physically happens. But if it says explain, which is where all the heavy, high-value marks are hiding, you absolutely must use our cause and effect chain. Second, the Peel framework application. Point, evidence, explanation, link. This perfectly maps to our 4 steps of identifying the quantity, stating the relationship, explaining the physics, and connecting to the observation. Third, and people mess this up all the time, the time management matrix. When you are sitting in that exam hall, you need to roughly allocate 1 minute per mark. So if you see a juicy 4-mark explain question, you have exactly 4 minutes to calmly and methodically draft those 4 steps. Do not rush it in a blind panic like Sam did, and do not just brain dump every equation you know like Alex did. Be the strategist. Stick to the spell.
Now let's see how this completely transforms your daily revision. I want you to practice these 4 quick recall prompts aloud. Whenever you're studying any micro topic in the syllabus, ask yourself, what is the core idea? What changes physically? What quantity or graph actually shows it? And where is it used in the real world? Let's test it on action and reaction. The core idea? It is equal and opposite paired forces acting on completely different objects. What changes physically? The acceleration or the momentum of those objects. What quantity shows it? A vector force arrow or force time graph. Where is it used? Rocket propulsion, a person walking, a high-speed car crash. Listen to me, students who implement these physics strategies see an average improvement of 2 full grade boundaries. Let that sink in. 2 grade boundaries. But that only happens if they practice consistently with these explainers. You have to actively ingrain these 4 questions into your daily study habits until they become second nature.
Look at that progress bar reaching 100%. You now possess the exact structural spell needed to completely dominate these exam questions. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. I want you to apply our framework to this final provocative question right now to truly test your mastery. Think of something we haven't even discussed today. A swimmer doing a flip turn off the pool wall. The rotors of a helicopter slicing through the air. A heavy textbook just resting quietly on a table. Try to build that 4-step cause and effect chain in your head right this second. Map out your answer and see if you've really mastered the spell. Drop a comment below with your target grade for physics and the biggest challenge you're facing.
Seriously, get in the comments because our team responds to every single comment. Like and share this video with a study partner. Help them build their own frameworks so you can both crush these exams. Keep practicing, always focus on cause and effect, and remember, ace the exams. Your Cambridge success starts here.